Okay. Now, moving on to diffraction grating. It's yes, it's a structure question. So we have this question here. Monochromatic light wavelength lambda is normally incident. When you see normally incident, don't worry about it. All the diffraction grating equation is assuming that the light has to fall normally on the grating. See, it is falling normally on the grating. So that don't let you assume that this theta is 90. This is the angle of diffraction. Okay. Yes. The diagram shows adjacent slits of the diffraction grating labeled B, W, X. So, light waves are diffracted through an angle to form second order diffraction maximum. Points Z and Y are labeled, as we can see that. State the phase difference between the waves at V and Y. Because the question says it is forming a maximum. Therefore, the phase difference between them has to be 0 or 360 degrees. Because it's a max. If it was a minimum, we would have assumed it as 180 degree out of phase by 180 degree. Okay. Yes. Moving on. State in terms of lambda the path length between X and Z. Path length between X and Z. Where is X? X is here. And this is Z. And it is forming a second order diffraction. So the path length between W and Y, because it's a second order, it will be 2 lambda. Then we can see that from the diagram itself, this is, sorry, XZ is double WY. So 4 lambda will be the path difference between X and Z. If it was a first order, WY will be 1 lambda, XZ will be 2 lambda. If it was a third order, WY will be 3 lambda, XZ will be 6 lambda. So you need to be careful about these numbers or the order of diffraction that they are giving. Therefore, I will say here the path length or path difference will be 4 lambda. Now, the separation of adjacent slits is D. So we have these slits here, right? Separation is small t. Show that for the second order diffraction maximum, 2 lambda equal to d sine theta. So we are going back to the diagram, so it becomes easy for you to understand. So here, this is theta, which means this angle will be, I'm going to shade that. Okay, so this angle is theta. Now, let's take, because the equation here you can see it is talking about sine theta. So I'm going to take the sine theta here. So sine theta will be equal to opposite side. This is the right angle, right? This is the right. Yeah. So opposite side, which is XC upon hypotenuse is Vx. So right now we said XZ is 4 lambda and Vx is from here to here. 1 is D, so it will be 2D. So cancelling 2. So we have sine theta equal to 2 lambda upon D or D sine theta equal to 2 lambda. Let's see whether that's what they have to prove or they want us to prove. 2 lambda equal to d sine theta, correct. So we prove that. Now, 11D. Monochromatic light, again. Monochromatic light means light of single wavelength. So, wavelength is 633 nanometer, is normally incident on a diffraction grating. The diffraction maxima on a screen are detected, and their angle theta to the central beam is determined. The graph shows the variation of sine theta with the order n of the maximum. The central order corresponds to n equal to 0. So light is falling on the diffraction grating. We get 0th order, we get first order, both sides first order, we get second order, we get second order. When we say order, these are talking about the maximas. So this is the first maximum, this is the second maximum. Yes. Determine a mean value for the number of slits per millimeter. Oh, usually the question talks about meter. Now here this is talking about millimeter. So let's just keep it circle. Later might be we need to adjust it. Okay. So mean value for the number of slits per millimeter of the grating. So they are asking for capital N per millimeter. Okay. So what's the equation for diffraction grating? N lambda equal to d sine theta. Of course, I have told you, whenever you're talking about a graph or whenever you have to use the graph, it will be either a gradient or area under the graph or y-intercept or x-intercept, right? So the question is asking you to find out capital N. So let's rearrange this equation, giving you 1 by n sine theta. Now let's see, I want n. So n equal to sine theta upon n lambda. Okay. So what do I have here? Sine theta on the y-axis and smaller n on the x-axis, which is giving me ratio of sine theta to n as the gradient. So I'm going to rewrite this equation as gradient because sine theta upon n is gradient upon capital lambda. Sorry. So let's find out gradient. Let's look at a beautiful point. So I have chosen this point, okay, not literally that dot, but that corner. So n equal to 3 and this is 0.24, right? 2, 1, 2, 2, 2. Yes. So 0.24 upon 3 is giving me 0.08, right? So gradient is 0.08 upon the lambda value they have given us in the question, 633 nanometer. So 633 times 10 to the power -9 nanometer. So when you solve this, you get the number in meters. The question is asking for number in millimeter, which means you need to divide this answer further by 1,000. So number in millimeter will be equal to 0.08 upon 633 times 10 to the power -9 times 10 to the power 3 because you are dividing the whole thing by 1,000. All right. So you will get the answer. Please solve it. State the effect on the graph of the variation of sine theta with n off using a light off, because they're talking about the effect on the graph using a light source with smaller wavelength. Smaller wavelength. Think about it. So our equation is n lambda equal to d sine theta. So gradient will be, as we mentioned before, equal to sine theta by n. Sine theta by n, which will be equal to lambda upon d, right? I'm rearranging the equation. Now, when the lambda is decreasing because it's a smaller wavelength, what will happen to the gradient? The gradient will also decrease. So we will get a straight line with smaller gradient. Because the question is asking for the effect on the graph. So therefore I'll write a smaller gradient. Now, again the question is increasing the distance between effect on the graph. When you increase the distance between the diffraction grating and the screen. Let's look at this equation. Does it contain any capital D? Because that's what distance between the slits and the screen is capital D, and this is not relevant here. Therefore, we'll say no change. Okay. Is that clear for you? Now, let's look into question number 12. So we have monochromatic coherent light. Monochromatic means light of single wavelength. Coherent means light waves that are in phase or constant phase difference. So monochromatic coherent light is incident on two parallel slits of negligible width, a distance d apart. So a screen, so distance is d apart. A screen is placed d from the slits. Point M is directly opposite the midpoint of the slit. Of course, we know that the directly opposite point will always be a bright spot. Okay, moving on. Initially, the lower slit is covered. What does it mean? So it is talking about a single slit. Then, when one of the slits is covered, only one slit is working. So single slit. So due to single slit, the intensity of light at M due to upper slit alone is 22 watts per meter square. Okay, they're talking about intensity. What's the relations between intensity and amplitude and distance? We know that intensity is proportional to amplitude square, intensity inversely proportional to distance square. Okay, just randomly I mentioned it, maybe it is useful, let's see. So M, intensity of light at M due to upper slit alone is 22 watts per meter square. Lower slit is now uncovered. So now both the slits are working. Deduce in W meter per meter square the intensity at M. So now you have both slits working. Yes. So what will be the intensity? Of course, when you have one slit, we can say one wave is reaching. When you have both the slits, two wave is reaching. Now, of course, we know that this is a bright spot. That means constructive interference is happening there. When it is constructive interference happening, two crests are getting combined, giving rise to a bigger crest. So the amplitude is doubled. So intensity with one slit is proportional to 1 amplitude square, which is equal to 22. Intensity with 2 slit is proportional to 2a the whole square, because it's 2 amplitudes and it has to be squared, which is giving me 4a square equal to x. So I want to now compare or find out the value of x. So what do? I'll take the ratio. So I'll write a square upon 2a the whole square equal to 22 upon x. So a cancels, 2 square 1 upon 4 equal to 22 upon x, or x equal to 4 times 22, which is 88 watts m minus 2. Usually the students do is the intensity is doubled. No, intensity depends upon the amplitude square. Therefore, you need to be a little bit careful here. Yes, let's look at 12b. P is the first maximum of intensity. So they're talking about here. This is the first maximum of intensity. On one side, following data are available. Small d, which is the distance between the slits, equal to 0.12 millimeter. Capital D, which is the distance between the slits and the screen, which is 1.5. And distance MP is 7 millimeter. What is MP? Okay, so from one fringe to the next fringe, so that is the fringe width. So this is equal to x. Calculate in nanometer. So this is a specific question. The wavelength lambda of the light. So yes, we have this equation, x equal to lambda capital D upon small d. So we want lambda equal to x b upon capital D. X is what? 7 millimeter. So 10 to the power negative 3. Small d is 0.12 millimeter. So 10 to the power negative 3, because we need to write it in SI unit. Capital D is 1.5, which will give me 5.6 times 10 to the power negative 7 meter, which is 560 nanometer. Now, okay. The width of each slit is increased to 0.30 millimeter. Previously, remember, it was a negligible width. Now the slit width is increased. Capital D is D and lambda remain the same, so there's no change. Suggest why after this change, the intensity at P will be less than at M. So with this, here they are talking about interference. Now what happens is the intensity is decreasing. So from negligible width, now the slit width is increasing. So here two things are happening, interference and diffraction. That's why they are asking this question. The intensity at P will be less than at M. So previously the pattern was all of same height. This. Now, when the slit width increases, the pattern will get modulated. So we'll have sorry. This should. And here, those small ones. So this will be. Why after this change, intensity at P will be less. So here, this is P. This is M, the central one, and this is P. The question is why intensity at P will be less than that at M. So what will I write? We'll say as the slit width increases. So you need to say slit width because that has to be referred. When the slit width increases, diffraction becomes prominent. Okay. So what happens? The intensity pattern will be modulated by single slit diffraction, making intensity less. This is how you need to frame the answer. So you take that 1 mark. Remember, you need to say the diffraction is taking or having an effect on the interference pattern. Now, next question is 12D. Show that due to single slit diffraction, the intensity at a point on a screen of distance 28 millimeter is from M is 0. So we have it here. Now the slit is no more fine, what you say, negligible. It has some width. So now this is the 0 order or the central maximum. We are talking about one that is somewhere here, which is 28 millimeter away from M. Okay, here it is a minimum intensity. We need to show that. And it is due to single slit diffraction. So that means I need to talk about theta equal to lambda upon P. Right? So we need to see what is the value of theta that we are getting. Lambda, of course, they have given us 560 nanometer, right? Yes, we calculated it here. So it is 560 times 10 to the power -9 upon B. We have, or they have given it here, 0.03 millimeter. So 0.03 times 10 to the power -3 is, when you solve it, it will give an answer 0.018. Okay. Of course, it's in radians. Okay, now, so this is for minimum, and I'm getting this answer, but I also need to see whether it is forming the same angle here. Right, so they have given distance as 28 millimeter, and they have given the distance between the slit and the screen as 1.5. So we have this as 1.5 meter. This is 28 millimeter. By using the concept of angle, let's see what is the angle. Angle equal to arc upon radius. So we'll find out theta equal to 28 times 10 to the power -3. Angle equal to arc upon radius. I'm using that equation. So this is the arc 28. Radius is 1.5. When you do that, here also you will get 0.018. Yes, so the angle formed here is corresponding to a minimum angle. Therefore, the intensity at M will be 0. I hope it's clear for you. I'll solve a few more questions in another video. I'll share it with you. All right. So